Let's take a look at number 7c. So we have a couple of technical details on this one. We have a plus b times the square root of q divided by c plus d times the square root of q. And q in this problem is assumed to be a rational number that is not the square of another rational number. In particular, q could be a negative number. So case 1. Would be that q is a positive rational number. Then we multiply by the conjugate of the denominator. So we get a plus b times the square root of q times c minus d times the square root of q divided by c plus d times the square root of q times c minus d times the square root of q. Okay, now multiplying out. On the bottom, q is known to be positive, and so we get c squared minus d squared q. So multiplying the top, to get the terms that are real, we get a times c minus b times d times q. And this works because we know that q is a positive number, divided by c squared minus d squared times q, plus, then we have the square root of terms that have a square root of q in them, so that would be bc minus ad divided by c squared minus d squared q times the square root of q. So this looks like it has the required form of a rational number plus a rational number times the square root of q. However, there's a couple things that we need to check. First off, we know that c squared minus d squared q cannot be equal to 0. Okay, so that's one thing that we need to check, that we don't have a 0 in the denominator. Now, why don't we have a 0 in the denominator? Well, if we know that q does not equal c over d quantity squared. By assumption, q is not the square of a rational number, and so we know that the denominator there cannot be 0, therefore. Also, we need to state that using the field axioms, we know that a times c is rational, b times d times q is rational, so a times c minus b times d times q is rational, c squared minus d squared times q is rational, therefore this is rational. Same for this one. So we have to actually formally state that by using the field axioms, we know that the terms in front are rational. Okay, so that's the first part under the assumption that q is a positive number. A common mistake was to ignore the possibility that q could be a negative number. So this is case 2. Okay, now a typical example for this would be, was actually given in problem number, part B of this problem, where we had 1 plus 7i divided by 5 plus 3i, where q is equal to negative 1. We have to be careful with this case because the rule square root of q times square root of q equals q only works if q is positive. That is a false statement if q is negative. So the way that we're going to proceed here is that we'll write this as a plus b times I times the square root of r divided by c plus di times the square root of r, where q is equal to negative r. So for example, if that square root is negative 7, this is I times the square root of 7. So now q is negative, so r is positive, And so I can proceed very much like I did before. We have a plus bi times the square root of r times c minus di times the square root of r divided by c plus di times the square root of r times c minus di times the square root of r. Okay, so the denominator is now c squared plus d squared times r when you multiply out. So we get a different looking thing here. And then if r is equal to negative q, then we get the same as before. Okay, on top we have AC. Then I have I times negative I gives for plus, so plus B times D times R. Then finally we have the remaining terms where we have B times C minus A times D divided by C squared plus D squared plus R, or D squared times R, times I times the square root of R. And I times the square root of R can be replaced by the square root of Q, because the definition of I. And then proceeding as before, both of these numbers are rational. The denominator here also cannot be equal to 0, using the same logic as before. And so this has the required form capital A plus capital B times square root of Q. So the mistake that a lot of folks made here was just simply not accounting for the case that Q could be a negative number.